JavaScript Application Architecture Crash Course of EventEmitter and EventCorrelator. Ooh. This is a crash course. It means a lot of words in a little time. It is unfair. A crash course is never fair. If you like it, the more you re-listen to it, the more sense it will make. If you don't. Because application architecture is simple by design, and this does not do it justice. You should not stress about application architecture. It's never too complex. This text exists to give you an overview of the full thing. It is a Picasso that you have to comprehend in time. If you just glance at it, it will seem scary, and that is not fair to the architecture. The modern application architecture must be simple, and it is indeed poetic. It must be able to carry the burden of all the features that you add. I recently spoke of signals or reactive variables, showing how user interface forms and even manual layouts connect together. Bunch of weird syntax on top of some oddly clear things. Now you need an overview of the application architecture that hosts that code inside little plugins. There used to be many different application architectures and ideas, but with AI, the simplest one won. As little misdirection as possible, clear information over magical convention. That's actually backwards to what people used to be doing. They were doing frameworks based on conventions rather than extended information and verbose programs. First of all, no one mentions EventCorrelator when introducing the EventEmitter, so you can be sure that this is going to be a fun ride. I am a firm believer that real programs use signals, and that any program that does not use signals is silly. But signals just store values. Applications need a little bit more than that, especially now that AI prefers plugin architecture. Lots of little pieces that it can work on and replace independently of the rest. And all your plugins should listen to the main app for events such as project load and project loaded, file save and the resulting file saved. I won't waste your time. Events must come in pairs. The first one is like a command or an action. It executes the function. The second one announces that the job is done, and whatever wants to follow can follow. The first event is a trigger, and the second, an announcement of the job well done. This is how you stack the base and already rather frighteningly complex operations in your application. You listen for completion of something that you absolutely require, and then you run your thing. This kind of execute command and announce when the command finished may sound primitive, but applications are incredibly complex beasts, and you need that primitive simplicity at the very bottom. It is important that I should mention that event handlers that are triggered by the events are the perfect functions to mark async, which then lets you use the await keyword and then helps you write much cleaner code without any tricks, such as giving a function to a command and waiting for that command to execute that function when it finishes. Here the problem is that yes, that function will execute, but all the stuff below that line will have long finished executing. With async, you can await an entire line of code and just sit there until it yields some result. So event handlers are usually very tiny, and event emitters love anonymous functions, regular functions, async functions, and object methods equally. They don't care. So if you need to await something to simplify your code, no problem. Just mark the function executed by your action event as async, and you can keep it nice and simple without upsetting the rest of the program. Many programmers don't understand this and end up needing to mark everything as async, and things then slip out from their control. Event emitters simply give you superpowers. But please be mindful of that trick, that there is that do something and something got done pair of events. This way, you are announcing to the application that something has started and, more importantly, finished, so that other things can follow it. Signals, just to be clear, kind of emit the value change. But if your user was to click the same button twice, you would not get a notification on the second click, because signals only announce when their value changes. So your user clicked button with ID signal that holds the ID of the button that the user just clicked will not announce the second click if it's the same button. Signals are for storing values. It makes sense, and it is in fact a great benefit, that if you set the same value to a signal, it won't do anything. For announcing things, you use events, which do not have values. Honestly, if you extend the event emitter and give it some value, you will just make a bloated, unstable, unthought out signal. And if you knock out the same value test in a signal, you'll just make a crappy and corrupted emitter that's missing important features. Signals are for storing values, and events for broadcasting messages. Oh yes, signal and event kind of mean the same thing. But that's actually your fault, because people like you are missing from the world of programming. Perhaps rename signals to reactive variables, or maybe something nifty like reactives. So you would have primitives like string and number, objects like array or car, and then reactives, variables that announce when they change. The world of programming needs new minds that can tidy up things. Finally, we get to those event correlators, stacking plugins in sequence of execution, where you wait for file load event to finally announce file loaded and then can do something with the data, is okay for program architecture. But when programs are running and the user is poking around in an unknown sequence, you will very often need to wait for 2 or more events, different names, but sharing some kind of a property. Very often, maybe an ID, or, as I encountered today, an ID in the main thing that also contains a type, and then using that little type as the waiting tag to make sure that you have your records and their types loaded. Normally, though, you just wait for the same ID. So you can listen for added to cart, went to checkout, and payment successful that each share the same shopping session ID. When restoring data, and also allowing the user to add data at random points, you don't know when an event will happen or which will occur first. Has something restored that has a particular type? Or did the user just add it by dragging something on their application desktop? In that case, all you can do is listen for both events occurring at some point and sharing the same ID or type or some other related property, so that then you know you got all the data you need to proceed with some new action. EventCorrelator combines multiple related events into a new event. Applications grow large enough for your mind not to be able to grasp them after a few weeks. And even if you can handle it, all it takes is a wonderful vacation to change that. But you can always be sure that you will be able to figure out the things you need to do whatever you are doing. And you just put them in the correlator, specify what ID relates those two events together, and voila! The correlator will emit a new event with the name that you specify, with the data of all of the events that it correlated. So you get to stay in control, no matter how complicated things get. There isn't much more beyond this. Everything that follows is easily handled by artificial intelligence. And to make sure that it does it right and not in some maverick way, you say, do it in the MDN style of programming. That's the Mozilla Developer Network. And whatever it is, working with sound or generating songs or kind of a template engine, but not really because you need all the different events in all the right places, the AI will take care of it. If AI ever fails you, or you feel like you need to rebuild something, that's where the plugin architecture becomes supremely useful. You ask the smartest AI you got to create a requirements document based on the code that you have, then tidy things up or tell the AI to optimize the idea, and then you regenerate the code, reflow it, make it simpler. Rename the existing plugin as .old1, and then just paste in the new code. To be clear, designing low misdirection applications that AI can easily help with demands the use of application object that extends EventEmitter, plugins that listen to the application emitter, signals for various object properties that change often, and EventCorrelator to help you know when you get everything you need to proceed forward with your application features. In closing, the clearest example I can think of is the login information of a user, which you receive almost immediately, and then profile information from the server, for which you may need to wait. You correlate the two on the same username, and you wait until the resulting event is triggered. And then you take the data in that event and make the profile page. Lastly, the event emitter is only like 10 lines of code. It has an on method where you say my event emitter dot on start followed by a function, and then from within this function or some other function you can say this, because you are inside the event emitter now, emit, and then give it a name of an event and the data that will be included along with it. And if you use this kind of an event emitter as your core application object, everything that's connected to the application will be able to hear the event.